This video is part of CAE Associates ANSYS e-learning series. CAE Associates is an engineering consulting firm in Middlebury, Connecticut, specializing in finite element analysis and computational fluid dynamics. We have been an ANSYS channel partner since 1985 and have developed our ANSYS e-learning series to help you maximize your software investment. Please visit our website, which includes an extensive resource library with over 250 items and counting in an easily searchable area. We also invite you to visit our Engineering Advantage blog, where we share insights from our many years of performing engineering analysis. CAE Associates also offers an extensive schedule of ANSYS courses taught at our Middlebury office. If you need help deciding on the best courses to take for your application, visit our CAE University page. The complete library of e-learning recordings is available for viewing in our resource library and also on our YouTube channel at youtube.com/CAEAI.
Okay, so this is the part that we'll be using today just to demonstrate some of the features of Design Modeler. I should also note that all the attendees are muted, so if you do have any questions throughout the webinar, please just submit them to the chat window, and if there's any time at the end of the webinar, we'll try to answer them. Otherwise, I can always follow up with you through email. So there is also going to be a few polls given during this webinar, so if you could just submit your answers to them. They should pop up on your screen in the WebEx window. So today we're going to be featuring this CAD geometry that you see. This isn't really meant to be a training session. It's just going to be a demo of the features in Design Modeler and some of them that you can use to clean up the CAD geometry. We do have training classes that you can attend to see all the features of Design Modeler. So this is a part that I imported. It just comes in as a surface body. It shows up with a little flag in there. It was just a parasolid file that was imported. So this is a surface body, and we would like to mesh this with solids at the end of the day. So we're going to be going through the steps of cleaning up this surface body to get it prepared for meshing with solid elements, and also trying to take care of some of the complicated features in here, so we don't have to have as many elements in this part. So to start off with, one of the things that we can see right away in this is that there's some surface in here that came in a little strange. It's actually would be the back side of the face that we would like to have, or the negative of this cylinder. So we can take care of that by using a face delete operation, which is going to use the surrounding topology around that surface to fill it back into what it should be. So now we can see that's what it should have looked like initially, just imported, kind of strange. So that's good. That cleans up that location. That was something that was very easy to see right away. Something else that's easy to see right away is that this is a hole in this part. So one of the things that we can do to see that a little bit easier is to color the edges by connection. And in this case, it shows up as a red edge in there, indicating that it's a single edge or free edge. So if we know that, we can just thicken up all of the single edges that are in the model just to make this easier to find any other holes that may be located in this part. The black edges are shared by a couple areas, so it's not a free edge. So we can see that there are many locations in this model that show up in bright red, so we can see them pretty easily that those would be holes. You can zoom in and see that. So knowing that we have those in the model, we can easily search for them and repair them with the repair utility, repair holes. So this is going to find all the holes of any size in the model that we have, and we can just choose to find them right now. So it automatically detects that as being a hole. You can click through these and find all the locations that it found. If for some reason you didn't want to repair one of these locations, you can always choose to not repair it if you'd like. But we'll leave everything as is and make an attempt to try to clean up all of these holes that it found. So let me generate that operation. And while that's going, let's take our first poll. So let me just open that up. And I'll open the poll. So hopefully everyone can see on the bottom right of the WebEx window, the main window that you have, the question pops up: how much analysis time is spent prepping CAD geometry for meshing? So if you could go ahead and pick the answer that best applies, and then hit submit. And getting a bunch of people submitting. Like pretty much everyone has had a chance. Just let it go a few more seconds. Okay, and that's pretty much everyone. I'll close the poll at this point and show the results so everyone should see how much time is spent prepping CAD. And it looks like most people are spending around 10 to 30% of their time prepping CAD, which that's for the analysis process. That's a fairly substantial amount, just getting it ready for analysis. So hopefully there's some things here that you'll see that can help speed up some of the things that you might need to do to get it ready. So very good. Let's go back to Design Modeler. And we can see that operation finished. If I highlight this repair hole operation, some of the edges show up in green. Those executed successfully, and those are the locations that are highlighted here. But if we look down in the details, you can highlight these operations, and it did perform these, but there are a couple that failed in here. And here is one location that happened to fail. It wasn't able to create a surface patch at this location. So we can take care of this manually. It's not an issue. So let's first address this location. So we can see here that if I highlight this surface, it looks like it shares a common edge and then kind of goes up into the surface that's through here, through that edge. So it just couldn't figure out how to connect that up. So what I'm going to do is I'm going to remove this face from this surface body that we have in here. And I'll do that with a thin surface. And I'm just going to choose to remove that face. And it's just going to take it out of the surface body and leave us with what would be remaining from the other faces in here. So we should have a bunch of edges that would make this a little bit easier to clean up in this case. So you can see we got rid of that surface that went up and overlapped in there. So now we have another hole in the model indicated by the red edges. So we can fill in this hole by using surfaces from edges. I'll just select these edges here and create a surface patch over that. So, it's going to use the surrounding geometry to fill it in. And again, we have still red edges here, meaning that they're basically outside of a surface, or they're not joined. So we have two surface bodies at this point, and we'll eventually merge those together into one. But let's go back to the other location here that failed. So I'll highlight on it. It brings us to that location. And zoom in here. And I'm going to turn on the vertices so we can see. So we got a couple of vertices at each end of these two lines that are shared by those points. So it would be nice if we could just merge those lines together. And we can do that. That is with the tools Connect. And we'll connect edges. So let's grab those two edges right there. And it's going to join the edges within a tolerance here, which is 0.1 millimeters. So if I just kind of zoom in here and hold this up against my ruler down on the bottom, here we can see that the width of those lines is about 0.3. So that tolerance just needs to be greater than that to be able to connect them up through there. I'm just going to put in something a little bit larger to connect those up. So Great, that's much better now. We still have those same points, and then they're connected up that it turns black. So very easy to see that. So those are some automated, repair utilities, just a couple of them. There are also a lot of, say, small features in this geometry, right? I mean, if I look in this location here, there's a small little area down there. If I look at the area, it's 0.03 millimeters squared. There's also this slivered area in here. And if we have these in the model, when it gets time to mesh, the mesher is by default going to respect the bounds of all of these surfaces. It's going to put element edges along each of these lines, and we may not necessarily want to have that. That's going to require a lot of elements in a location like this, and we may not be concerned with all of that. So it would be nice if we could maybe join some of these smaller areas into bigger areas and clean up some of these things. So there's automated ways to do that, again, to make it more efficient when it gets time to mesh. So to start off, let's see exactly what we have in this model, because for the repair utilities, there are a whole bunch in here. We compare edges, seams, holes. You may not know what they are or if you have any. So let's see exactly what we have in the model. So under Analysis Tools, there's Small Entity Search. So we're going to search this body for any face that's less than, let's say, 1 millimeter. We could probably go smaller. Any short edges, maybe less than 1 millimeter. Slivers. There's a bunch of other things that you can check for in here. So when I do that, it's going to, again, go through this entire geometry that we have selected and see if there's any small edges, slivers, areas within the tolerances that we specified. And then we can see exactly where they are. And then decide if we'd like to use some of the automated repair utilities to clean these up. So just hide some of these. So we can see that it found 38 small faces, a couple of them in there, which we saw initially. And zoom back out. There's a whole bunch in other locations on this model we might want to clean up. Same thing with short edges. There's a whole bunch of these. You can zoom into some of these locations. The short edge right there. Maybe we want to merge those key points together. So things like this you can find if you have in your model, and just select on them, see where they are. So for this demo, we'll just look at the small faces and short edges to clean up. So now that we know that we have those, let's go in and take care of them. So repair faces, and it's going to search for faces. It just puts in a default tolerance in here. I'm going to make it just a little bit larger, just so it finds a few more. So have it go through and search in the model for all the small faces, less than 0.1 millimeters squared. And we can click on all these. And again, if any of these we did not want to clean up, we can choose to not repair them if we'd like. So let's go ahead and just repair everything that we have there. And then when we click back on this entity, we can see the locations that it cleaned up in there. So it took care of a small face in some of these locations that we used to have. So those are taken care of. We also said that we had some small edges in here. So let's use that one as well. So repair edges. And I'll just leave that as default. That was much smaller than what we had initially searched for, but that will be a pretty small distance in this model. So this one is really just going to connect up the vertices to get rid of that small edge. So you can click on all these different ones through here. And if you zoom out, we can find this location and see that, that location is pretty small. You got to go way in to find it. So we'd probably want to get rid of things like that. Don't really need to have an edge length in there that small. That's going to put in a lot of elements if we don't do anything else on the meshing side. So I can highlight on that entity. Again, it shows the little vertices here that have been repaired or connected up now. So that's one point between all those surfaces where there used to be a small edge. So that's much better. Okay, let's just take another quick poll here. Let me stop sharing and open up the next one that we have. Okay, so the next poll question is, how do you currently defeature a CAD model? So I'll open that poll up to you again. If you can just go to the window and submit your answers. And I'll give it another 30 seconds or so for everyone to participate. And it looks like we're getting more than half. Everyone is almost 80% of the way there. Still going. And it looks like pretty much everyone's had a chance to submit their answer. And okay, I'm going to close the poll. Looks like everyone that's going to participate has. So I'll display the poll results to you. And how do you currently defeature a CAD model? Looks like a mixture primarily of some design modeler, some CAD. Some have another tool, and some don't defeature. Maybe you just have a lot more elements in the model and don't worry about defeaturing. It's an option too. Looks like also many do use CAD, and so quite a mix here. Not really overwhelming on one answer. So interesting. Okay. Well, let's go back to Design Modeler. So those were some of the automated utilities that are available. Now let's do a few manual operations. So the next thing that we could do in here is, a lot of these surfaces that we can see, there's a whole lot of blends in here. Maybe, this location, filter. All of these surfaces, maybe even in smaller locations, we could have cleaned some of these up, but, it would be nicer if some of these surfaces are larger than they are, not broken up so much. So maybe we try to clean up some of those things. And we can also do that in an automated way, too, with the merge. So we can say to merge faces, and automatically, based on some tolerance or angle, really, we can search for through the body and then cluster all the surfaces together that are within a certain range. So this is what it found on this model. So it's going to try to combine, all of these four faces into one in that cluster, and it found, over 200 in here. If there was something that we didn't want to join together, maybe just this face, for instance, that's kind of large. That's going to be one cell or treated as one surface for the mesher. Just click on it, right-click, and remove that cluster, and then it won't join those together. Maybe we don't want to have these long surfaces all joined together either. Just right-click on it, remove. It does color them for you so you can see what it's going to do. And this is going to take a little bit longer than I feel like waiting at the moment. So I'm going to delete this, but just showing you what it would do. And I'll just create one manually. So I'm going to merge faces manual, and maybe I go in here and click on these four faces right there. Create one cell out of all of those, and then merge that together. So it gets rid of those small edges and that would have been there otherwise. So that's a much cleaner surface to have. And again, we're doing this only for meshing purposes. So then the mesher, the elements don't need to respect the bounds of those small faces anymore. It can fill that surface. So really in terms of making it easier to mesh, getting a more simple topology on the geometry. Not to say you can't do some of this on the meshing end as well, but this is to show you how to deal with it on the CAD side. So those are some cleanup things that you can do. We can also build some geometry too. Maybe we are missing the bolt that would go in this hole. This is a motorcycle frame, so maybe there's a connection that would go through here that we're concerned about. So let's put that geometry in. at the moment. So if we wanted to put in something, a bolt at this location, I'll just select those edges right there. And I'll extrude those edges into a solid body or solid part in this direction that we have shown here. Maybe I'll flip that the other way. So the edges in gray here show the direction that this is going to go in. And maybe I'll also go the other way a little bit as well, maybe 5 millimeters, have this bolt go all the way through. So, and then we have some connection there. We could put some boundary conditions on, and we get it to analyzing this and put in some contact at that location. That's something that maybe we could do. Well, that's easy enough, though, because that was just a straight hole. What would we do with the surfaces in here? If we look at this, these are kind of off at a taper. So the cross member that goes in this location, that would be connecting up, has a taper to it. So it would be nice if we could just take these edges and extrude them in the normal direction inward to create a solid body that would maybe then be used as a contact surface in the analysis in here. So the way that we could do that in Design Modeler is to just take a copy of these faces. So if we go in and use the concept menu here, face surfaces from faces, it's going to then create a surface body of those existing faces that we already have here. So we can click on this surface body and we can extrude it, but we're going to use a thin surface to do that. So for that body, we'll extrude it. It's going to be outward or inward, based on geometry, but let's just say 5 millimeters to give it some thickness in here. So now it took that surface body, turned it into a solid, and now it's a solid part in there. And the next step would probably be to take some of these faces through here and extrude them upward. So maybe you have a longer bar that would come in here in contact. Something you could do. You could also, a lot of other things you could do. But so that's just creating, some more geometry that we can use as boundary conditions for this part. So let's just take the last pole here. Let me open it up. Save these. Okay, the next poll question is, are you regularly using Design Modeler in your modeling process? So again, submit your responses. Let's see what everyone is doing here. Looks like more than half of you have submitted your answer already. And we're getting pretty close. And I think that's probably going to be about it. Anyone else going to participate? Okay, I'll stop the poll there. Looks like everyone that is going to. Come on. Oh, 4 seconds. Okay, let me open that poll up so you can see it. All right, so yeah, it looks like the majority of people are using Design Modeler in the modeling process. That's good. I mean, certainly if you don't have it, you can't use it, so can't fault you there. And may just go straight from CAD. And anyone that put in, no need training, but assuming that you have Design Modeler, you can certainly play around with it on your own too. We do offer classes. If you have any interest, either contact us or we can contact you related to that. But that's good. At least most of the people here have maybe at least seen Design Modeler at this point. So great. Let me go back to Design Modeler here and show you a few more things. So the geometry that came in here, if I zoom in at this location, they can see that there's a hole that was drilled through this part, and it partially comes through on one side. It would be nice to have that hole go either all the way through or maybe not partially through either. In this case, I'm going to say I'm not concerned with that hole, and I'm going to remove it. I'm also going to get rid of some other features in here that I might not necessarily care about either. The way that I can do that is to use, again, a face delete. So I'm going to select the surfaces that I would like to not be there or wish they were not in the geometry anymore. So maybe I just click on a couple surfaces here for that blend. Maybe I wish that wasn't there. Same thing with this boss up here. Maybe I would prefer that to not be there as well. You can select a lot of the geometry this way and then just use a face delete to rebuild the geometry as if those features weren't there. So it fills in that hole. I can see then on the back side, it put in the right blends to fill that back in. So some were a little easier than others for it to figure out what was going on. So you can always use face deletes too. You can go through and remove blends. It's probably a more useful one, but a lot of this geometry I may want to keep in here. So I guess lastly, we started off with this geometry being a surface body. It still is a surface body at this point, and we said that we wanted to mesh this with solid elements. And we would not be able to do that at this point. This would get meshed with shell elements by default. We do have, shown by these cube symbols, these are solid bodies that we created. So down here, that surface that I created, I'm going to select it with the other surfaces that form this frame, and I'm going to stitch them together with a body operation. And body operation sew is really what it uses. And if it can sew all these surfaces together and enclose a volume, then create a solid. So I'll choose to do that, and then it forms that together. Now that's part of a solid, and we have one large solid in here. So we could bring this over into mechanical now and mesh this at this point. So that's essentially it for the time that we have. In this webinar, we went through a bunch of the operations available in Design Modeler, but I certainly didn't cover nearly all of them. So, play around with it on your own, take a training class, give us a call if you have any other questions. So that's it for the presentation. Thank you for attending. Let me just see. Well, that's 10:30, so I don't want to keep anyone in here any longer. There was only a couple questions, so I can follow up with you individually by email. So the next webinar that we have, the same one is also given Thursday, but then we have meshing part 1 and 2, 3D solid shells and beams on these dates, and check us out online for what we currently have going on. So thank you again, and enjoy using Design Modeler.